My name is Katerina, and today we're going to talk about the use of new technologies in seabirds population assessment. First of all, I would like to do a little introduction about the importance of census. Why we do census? We need it to determine the importance of a site, and we need to understand the habitat in which the population lives, and try to have an estimation of the size of the population. If we manage to have a long time period of monitoring, then we will also be able to see if there's any changes, any variation in the size of the population, and try to understand why there's this kind of variations. Also, it would be useful to understand the dynamics of the population. Either terrestrial or aerial survey techniques have been used for the census until now. And today we're gonna focus on the use of new technologies and how they can help us to better assess seabirds population. Technological solutions differ depending on the nesting choice of the bird, either open surface nests like gulls or burrow nesting like cory. Using drones or artificial intelligence to monitor large colonies of seabirds can be as effective as traditional on-the-ground methods, while reducing cost, labor, and the risk of human error. Scientists have at the Duke University and Wildlife Conservation Society used a deep learning algorithm, a form of artificial intelligence, to analyze more than 10,000 drone images of mixed colonies of seabirds in the Falkland Island in Argentina. Monitoring the colonies have been using visual sensors, but is a laborious process, and the presence of the scientists can disrupt the birds' behavior. So to conduct a new survey, they use an off-the-shelf consumer drone to collect pictures that have been processed by a deep learning algorithm to analyze the image and differentiate and count the object capture. In this case, they were able to differentiate two very similar species of birds. Acoustic data are also used to estimate population size. There's a traditional acoustic monitoring where the researcher go and listen to the colony and make a rough estimate of the number of calls per measure of time. And then we have the automated recording units, which have long periods collecting acoustic data. And this technique has been used by Opel and his teams of research, and they assess the population size for nocturnal burrow nesting of chorus shearwater in the island of Corvo, here in the Azores. And these species of seabirds are highly vocal, and recent technological innovations such as the autonomous acoustic recording device make now possible to record and quantify vocal activity even in remote islands. And the acoustic recording is a promising approach for many biodiversity assessment and has been successfully employed, as in this case, to assess the change in seabirds breeding population. Another new technology is being used by Pickens and its colleagues while conducting a trial on European storm petrels in the Shetland Islands to test the viability of using infrared digital video technologies to census storm petrels. They found out that for the same fieldwork sampling effort, infrared filming generates slightly more precise estimates compared with playbacks. And this technique is still in development, and they suggest that probably using infrared footlights would increase the detection rates on darker nights that are the more challenging to study, resulting in a greater precision. I just have one last technique that I would like to mention, and it's the satellite imagery. It's been used by Fretwell and its teamwork for the first time, using a 30 centimeter resolution imagery from the WorldView 3 satellite. In Fretwell's study, he tests the accuracy of the satellite methods for directly counting individuals of wandering albatross in South Georgia. They successfully conclude that the groundbreaking resolution of the picture provided by the satellite give a step change in the ability to count albatross and other large animals, especially birds, directly from the space without the disturbance, and potentially having a lower cost and minimal logistical effort.